Everybody, welcome back to the New York Stock Exchange. This is Dave Vellante, and you're watching myself and John Furrier's coverage of the AI Factories Data Center of the Future. We're going to talk about the infrastructure stack generally. We're going to dig into networking specifically with Zeus Kerravala. He's the principal and chief analyst at ZK Research. Good to see you, my friend. Thanks for coming in.
Hey, Dave, how you been?
I've been really good, thank you. And, yeah, we're super excited to be here. The NYSE Wired plus theCUBE. It's been an awesome partnership, and it's great to have a super deep networking expert, but also somebody who really understands the market in general. Security, you and I have talked about a number of companies in that space. So, let's get into it. I mean, first, let me start with, people, I think, forget sometimes about the importance of networking in the whole AI. And, I know you and Bob have worked on some things in the networking AI summit. AI for networking, networking for AI, it sort of goes both ways. But explain to the audience why networking is increasingly important.
Yeah, it's a good question, and I agree with you. I do think people often forget about the network. And part of it is it's hard to understand, right? Like, with the GPU, Jensen goes on stage, he shows you a GPU, you can kind of conceptualize it. We all got used to Intel inside, so we understood the importance of CPUs. With the network, it's a little more nebulous, shall I say. We connect things, but we don't really understand how it works. At least most people don't. They just know when they click on google.com and it doesn't work, it must be the network, right? And so it's hard to understand the importance of it. But I think when you think about how AI has transformed the data center. And Jensen talks a lot about this, right? The new unit of compute. So the unit of compute was a server, then it extended to a rack, right? And in that case, the network played kind of an interesting role. It connected the rack, but it was all pre-built, and so it was hard. It was all one system. And then it expanded across the data center, and so now your network plays an important role, connecting all those things in the data center. And now, with their ability to scale out and scale across data centers, the network's the thing that makes all these GPUs talk to each other. So in fact, it looks like one GPU when in fact it's several GPUs scattered all over the place and increasingly all over the world, right? And so from that standpoint, from a back-end perspective, the network connects those GPUs. To the front-end network perspective, right, you think of all the training and stuff that's being done now, and our data. In fact, I wondered about this years ago, Dave, like, how would we manage data in an AI world? A lot of companies tried to suck all their data back to one location. That was too expensive, too complicated, too hard to manage. So now, increasingly, they're just leaving the data where it is, at the edge, on IoT devices, and they want their AI engines to be able to go get the data when they need it, right? And so how do you do that? Well, the network does that. And so front end, back end, wired, wireless, however you want to look at the network, it's the thing that connects the data to our AI infrastructure, which are GPUs, and makes AI work.
So there's sort of three areas that you talked about. There's sort of the scale up, which is all the NVLink 72. There's the scale out, and then there's the scale across. And it was interesting in the last couple of conference calls, you heard Jensen talk about how their InfiniBand business had doubled.
Yeah,
which was unbelievable. Everybody says InfiniBand's dead. And then their Ethernet business is growing like crazy. And then they sort of introduced this, scale across concept. And then you heard Hock Tan, which was really interesting in the Broadcom earnings call, saying, yeah, the other guys, their NVLink 72, they can only scale up, 72. And we've got, hundreds and hundreds. And so, but he was kind of playing games there with the definitions, right? It's really kind of scale out. Can you explain that?
With the scale up versus scale out?
Yeah, well, the way, I don't know if you heard Hock's comments. Yeah. He basically trying to deposition InfiniBand.
Look,
and saying Ethernet scales. And now, of course, NVIDIA has Ethernet too. So it's kind of this war of leaders.
This InfiniBand versus Ethernet war has been in place a long time, actually.
Yeah.
And in no way do I think InfiniBand's going away. In fact, if you talk to Jayshree at Arista, she always says never bet against Ethernet, and I think both can be true.
What does she say? Sorry,
never bet against Ethernet, right?
Yeah. Oh, yeah.
It's one out of overall. If you roll back the clock like 30 years, there was all these different protocols, and Ethernet beat them all.
Right.
InfiniBand is the last man standing, but InfiniBand has a lot of really unique characteristics. it's highly deterministic, it's lossless. And so if you need guaranteed performance, and no matter what cost, right? Like I am connecting a backplane of GPUs in an NVLink type scenario, so within a box, it's great for that, right? So you can have InfiniBand grow and Ethernet grow at the same time because we're seeing AI scale up, scale out, scale across. And I think over time what happens is InfiniBand gets used for cases where it's a fully integrated system, something like NVLink, where I'm connecting GPUs within a box. And then as I start to scale out and across systems, Ethernet's a better system for that because it's something people are familiar with, they know how to work with. And to the vendor's credit, Ethernet has come a long way. Like when the AI boom first started, Ethernet was not in a position to take over to replace InfiniBand. But it's even without the UEC, the Alternate Ethernet Consortium, vendors like Arista, Cisco, companies like that have improved the lossless nature of it and made it more deterministic to closely match InfiniBand. But I do think, in fact, Worldwide Tech did a study where they compared Ethernet and InfiniBand, and they said that the difference is there nominal, but if I'm running some super intense workloads and I'm Amazon and Microsoft, that nominal little bit makes a big difference, and I'm likely to go with InfiniBand. If I'm a general purpose enterprise, big banks, pharmaceutical companies, that nominal difference isn't going to make a big difference to me, and so Ethernet plays a better role there.
Now, there's also nuance.
So both can win.
Okay, and so, but there's also nuance. I'd love for you to explain this within the Ethernet world. So NVIDIA would say, well, we do Ethernet too. We love open standards. Our Ethernet, they call it Spectrum X, is purpose-built for AI versus generally off-the-shelf internet. I'm sure Broadcom has a response to that, but I haven't heard it, but I'd love to. How much of a difference does that make? Is a purpose-built, for AI Ethernet, something that customers should think about? What are the trade-offs with sort of, I think they're both standard, but maybe it's standard like Unix was standard. I don't fully understand. Help us parse through.
Yeah, in fact, that's a great comparison because I started my career as a Unix developer, and on an IBM machine, and I could not take code and port it over to an HP machine.
AIX versus HPUX.
Because there were subtle differences in how it worked. So at the very base level, Ethernet's Ethernet, but you can do a lot of things to tweak the performance of it, and that's what Cisco's done with their Silicon One. That's what Broadcom's Tomahawk, Chip certainly has done that, and what Spectrum X has done. So they all have their different flavors of it, but they are all purpose built for AI now. So
let's up level a bit.
So I couldn't go grab a wiring closet switch.
Yeah. Right.
Yeah.
So you work with a lot of CIOs. You run IT shops. What's the blueprint for the AI, for the networking component, for the AI factory for CIOs and enterprise architects? And I'm specifically interested in enterprise AI. We know the cloud guys, we know the neo clouds, they're crushing it, they're spending CapEx like crazy, they're able to raise a bunch of money, hundreds of billions of dollars. But what about the enterprise? How should CIOs and enterprise network architects be thinking about the future of AI factories and how they should be architecting their network?
I think initially, in fact, the best comparison I can think of is in the early days of private clouds, in cloud buildouts for enterprises, companies like VCE offered you these fully integrated stacks. Now, they were built off, VCE was VMware Cisco EMC, right? So it was made up of multiple vendors, but it was a reference architecture of a pre-configured, validated design for private cloud.
And it was a SKU that made it simple to sell.
Yeah.
Right.
And then over time, what happened is we got good at deploying this stuff, and we didn't need the turnkey nature of it anymore, and everything's opened up. And I think you'll see the same thing happen with AI, is you will see companies, you see Cisco and NVIDIA working together, Pure Storage and Arista have a partnership with NVIDIA as well, and building out a turnkey system. And so these turnkey systems, to me, are the right way to go for an enterprise, because when you start to deploy these things, there's a lot of dials you can turn and levers you can pull in order to tweak the systems. So you can spend months doing it yourself, or just use these validated blueprints that all the vendors have now. That'll make sure that when you deploy it, it's deployed in a way that you'll get the performance you need. And then over time, what'll happen in a few years, we'll open these things up and we'll be able to pull components from anywhere and build it ourselves. But in the initial term, I don't think there's enough build-outs to know what the best practices are. And so that's why the validated designs are important.
Okay, that's super helpful. So paint a picture just from a conceptual standpoint. I remember in 2010, Jay Shree came on theCUBE and she was explaining to John and me, she's like, Dave and John, what's historically happened is network traffic was north-south, and now things are changing, cloud, hybrid cloud, and it's going east-west, and that's the game, the trend that we're leaning into. So now you've got sort of both the pendulum swinging back to scale up because of the training clusters, and you've got, massive scale out, and you've got across data centers.
Yeah.
So will that mental model migrate into the enterprise, or is that really, the sort of cloud, neo-cloud, giant bank framework?
I think initially it's the cloud, neo-cloud, but I do think enterprises need to start thinking about it too. I'm not saying your 1,000-person regional bank is going to ever need that. They're probably going to do their stuff in a cloud. But if you're a global 2,000, I do think that you do need to think about how to re-architect your data centers. And I do think, because for a while, everybody just worried about scale out. And that's why the leaf spine architecture became so popular, right? You can just add more boxes and you just scale your data center, as wide as you want. But I think within these clusters now, you do have to worry about vertically integrated performance as well as performance across racks. And again, it comes down to Jensen's comment about the new unit of compute. What is the new unit of compute? It is your entire data center, right? And so, or multiple data centers, and that requires scale up, scale out, and scale across. And so from an Ethernet perspective, you got to think about the performance requirements within the rack, cross racks, and across data centers. And and that's why even with NVIDIA's integrated optics, the co-packaged optics, that becomes important because now you don't have to worry about the little bit of performance loss from pluggables and things like that. So,
okay,
there's been a lot of innovation.
Yeah, I want to ask you about. I wrote a piece. It was kind of tongue in cheek, but there was some, data behind it, which was the new Jensen's law, which is buy more, make more. And the corollary there, buy more, make more.
Save, right?
Yeah, the more you buy, the more you make is how we sort of altered it. And then the more you buy, the more you save. And then the corollary is that the network utilization factor, if you can take your network utilization from, say, 65% up to 85%, NVIDIA made the statement, the network is essentially free. Well, it's economically on balance, you get the network. It's economically, neutral. Let's call it that. Okay, so I think that law holds up in certain cases when you're GPU constrained. When you're energy constrained, when energy is really the main constraint, and where your network utilization is low. When that's not the case, which it may not be for a lot of enterprises, then that law may not be immutable. But from a networking standpoint, based on what you've seen so far, how underutilized are those networks? What's the opportunity as new cycles come out? Instead of Moore's law every 2 years, we're seeing upgrades every 1 year, doubling or tripling the performance every year. And that has network implications. If my network is underutilized and I'm able to utilize it, to a greater degree, at least for a couple waves, that's going to be economically neutral. What's the truth there?
Yeah, historical network utilization in a data center, 30, 40% maybe, really highly utilized ones, 60%. And part of that is once you got there, even with, a lot of networks, you'd start getting a lot of congestion with Ethernet, right? And that's where the limitations came from, and like I said, with a lot of the newer systems, Tomahawk, Silicon One, that's all been cleaned up. And so you can push so you can push the bounds of that a little bit more.
So will network utilization, and I guess the 65%, I'm talking really efficient operators, the cloud guys, right? Okay, the neo clouds versus the enterprises are probably still in the 30%, just like servers were, pre-VMware. Okay, so will that change?
Yeah, I think so. I think these things get more efficient over time. And let's face it, whatever data we've got today, and in fact, I saw it, what was it, the Splunk event. G2 talked to Patel, the chief product officer of Cisco, was talking about how 55% of all data generated today is machine data, created by machines. So whatever traffic we're throwing on a network today, I mean, you ain't seen nothing yet. I think we're going to saturate our 800 gig networks, and the vendors are all toying with 1 terabit networking now, right? Which is phenomenal. I remember when the first terabit switch came out.
Yeah.
I was talking with Andrew Feldman. He was still at Forest City. That's really cool. We got a terabit switch.
Yeah.
Now we're talking about at a port level, right? And I just think with from an AI perspective, Dave, the race is on for AI to do more with the data you have. AI creates more data to work with, and I think whatever we see for volumes today, it's going to be dwarfed in a few years, and that's going to create these upgrade cycles that you said. I think companies historically in the data center have waited these 2-3 years to upgrade. I can see 18-month cycles now. As soon as the new chips, come out, from Broadcom, companies now are looking at, I should be upgrading as fast as I can. So
let's talk about the landscape in networking. It seems like the whole market is dramatically shifting as a result of extreme parallel processing or accelerated computing, whatever you want to call it. You've got the legacy, the switch, vendors, the network vendors like Cisco. You've now got HPE+Juniper as sort of a new competitor. You got companies like Dell that have tried to compete in networking in the past and really not been super successful. But now they're taking the NVIDIA stack with their AI factory strategy, so they get at the NVIDIA networking. So that's something that is monetizable. And then you've got, kind of the Supermicros of the world, Lenovo's of the world, which kind of are there in the infrastructure stack. Of course, Arista. So you've got a sort of a resurgence. It's almost a renaissance in networking for some of the reasons that you laid out before. Is the window opening? Is Cisco ripe for disruption? Well, how do you see the HPE+Juniper thing playing out? Can a company like Dell actually, compete in networking now with that AI factory strategy? What are your thoughts on that?
that's a lot of questions. Yeah, I think...
Pick your favorite.
Yeah, I think... so first of all, NVIDIA, I think in the last earnings call, said that it's $7 billion in networking revenue. Right?
Insane, right?
I mean, they're the second biggest networking company in the world. But a lot of that is Bluefield, the DPUs, things like that. And
I ask you about that.
Yeah, and embedded networking. But still, even just pure Ethernet switch, they're probably selling a couple billion, a quarter, which makes them a pretty big networking player. I think Cisco finally has its act together in the data center. If you had asked me this a couple of years ago, I would have said they're going to get, Arista is going to do to them what NVIDIA did to Intel and just run over them. But with Silicon One, and especially with the NVIDIA partnership, that to me is very meaningful, because I think while Cisco needs NVIDIA to create some AI relevance for their stack, NVIDIA needs Cisco for its distribution channel. Like, nobody does enterprise distribution better than Cisco. NVIDIA does not know how to run a channel. Like, they'll tell you that, right? So that is a great partnership. And so I think NVIDIA and Cisco will be there. I really like Arista. I think they're a fascinating case in a company that uses merchant silicon, Broadcom, but they tend to get the Broadcom chips in and deployed in their products faster, and through their software and good hardware engineering, they actually get markedly better performance than what you might get with a white box, right? So I think if from a high performance perspective, to me, those are the three: Arista, Cisco, NVIDIA. NVIDIA is going to appeal to the companies that want this fully integrated solution, right, I think. And then for companies that want more open, I think they'll use a mix of Cisco and NVIDIA. Juniper is interesting with HPE, because neither company has been really strong in the data center for a long time, but clearly with HPE's other assets and servers and storage, there's no reason why they couldn't build their own fully integrated stack, right? And that's what I'm expecting to see now that they've got the Juniper networking in there, because Juniper does do high performance well. They do service provider really well, but it's like over the last few years, they get so obsessed with campus and AI that they almost forgot about data center.
I want to ask you about just enterprise AI at GTC last year. I think you were there.
Yep.
Jensen laid out 3 vectors. I've talked about this a lot on Breaking Analysis and in theCUBE. 3 vectors of AI: growth, AI in the cloud, AI in the enterprise, and AI in robotics. And here we're really focused on AI in the enterprise. And the reality is AI in the enterprise hasn't taken off. Most enterprises, data centers aren't liquid cooled, right? And so,
yeah.
And they're not. It's not like the enterprises are sucking up all the GPUs, because the cloud guys are constrained, and they're still trying to figure out, okay, where's my ROI on AI? Having said all that, there's a lot of proprietary data in banks and insurance companies, and
they all want to keep it to
and
themselves.
they all want to keep it there. They say they're not moving that data into the cloud. How do you see that playing out when you talk to your CIO colleagues? How are they thinking about bringing AI and intelligence to the data, or are they saying, hey, we're just going to put it all in the cloud? What are you seeing?
No, I don't think it's going to the cloud. I think they're going to leave the data where it is, which is on their premise, at their edge, and then they'll almost try and bring AI to the data, right? But that's a big network play, right? And so I think this is also where you'll see the rise of the neoclouds. I actually think that's because if you are going to partner with a third party, like a cloud provider, data residency becomes important, right? So you're going to want it to stay in country. And so a lot of these neocloud providers are building, regionally, country-specific nodes, right? They're all doing that now. And so I think that's, in fact, you got some, like you look at what's going on in the Middle East, right? They're just, that part of the business has exploded, right? Building on all the neoclouds there. Yeah. So I think that'll be the avenue to AI for a lot of enterprises. I think the biggest of the big, though, will build their own data centers out. In fact, I was talking to the CTO about a month ago. He said that for the first time in like 20 years, he's been talking about data center expansion. Like they've been shrinking. Now they're trying to get their footprint bigger. I do think power is a problem, and I am hopeful that SMRs maybe play a role here. It's Climate Week in New York, actually, and that's one of the big topics here is how do you...
Small modular reactors, which is nuclear fission.
Yeah.
Right. Yeah.
For lack of a better term. Yeah.
Right. And versus fusion, which is going to take a little longer. So there's radioactive waste that comes out of fission. There's much less or negligible radioactive waste out of fusion, but it's probably 20, 35, maybe 32, maybe at the best where we see that.
Yeah. But I do think that's the big limiting factor today is the power. And you're right. Most of them don't have liquid cool, and that's where if I can buy these integrated systems with liquid cooling built into them that, maybe can be engineered to be a little more energy efficient, that's a big win, right? So.
What about security in this AI world? You and I have talked about security. It's kind of an adjacency of your research area. Sometimes you really get deep into it. How does AI change the security model?
Yeah, that's a great question. And I think we have yet to see the impact of AI on security. And so there's the obvious, like AI can be used to secure, for security administrators to do things better. But I think securing the data requires a different model. I think this model, this heavy firewall reliance we've had of trying to place them at strategic points of the network doesn't work anymore. And the whole concept of zero trust everywhere actually is the right model now. And I have to be able to limit what has access to data and what doesn't. And so your question has a lot of different vectors, right? So just from a utilization perspective, if I'm a user, there got to be systems in place that limit what I can put into ChatGPT or Gemini or things like that. So if I'm an accountant and I want to create an earnings script, I shouldn't be able to drop it in Gemini and say, create me an earnings script based on these financials 2 days before the earnings call, right? And it should be limited. But and so there's a lot of work being done there in helping companies understand how to create guardrails, what to do, things like that. I think from a protecting the data standpoint, though, that's where you're going to see the big shift. Because historically in data centers, we threw up a lot of firewalls to protect east-west traffic. That is an expensive model that's very resource intensive and requires a lot of constant changing. I think this model that Zscaler probably perpetuates better than anybody of to be able to deploy zero trust down to the individual server workload. And in fact, they've got a cellular partnership, right, where they can secure things at the SIM for IoT.
Right.
That's, to me, that I'm not sure how the world can evolve, the security world can evolve without fundamentally changing the model where I break away from these appliances to something that's a lot more software-based.
All right, we got to go. So it sounds like Ethernet with UEC or InfiniBand. The answer is yes, 2026. Both.
I mean, both can be true.
And then what's the biggest gotcha you see in AI network, like proofs of concept that CIOs and architects should be aware of? Like, what should they watch out for?
I think just the performance. I think not underestimating the amount of traffic you're going to generate from AI, because these network builds take a long time and they're very expensive. And so whatever you think you're going to have for traffic, I think your estimates are conservative. Yeah.
So GPU utilization obviously very, very important, but so is network utilization.
Yeah. In fact, you require
That's dollars.
Yeah. In fact, Charlie Giancarlo, the CEO of Pure, said this to me when he joined Pure, because I kind of joked, you're going to a storage company.
And he's a networking guy, right?
Yeah. He says you need 3 things to make sure your AI works: fast storage, fast network, and fast processor. Right? Everybody understands the role of GPUs, right? If your network speeds don't match what you're trying to do to the GPU layer, and your data access speeds on the storage side don't match that, one of those as a weak link will create the whole system to not work properly. So the 3 of those things have to be in lockstep with one another. And again, that's why I'm a big fan of these validated solutions.
Zeus Kerravala, thanks so much for coming on theCUBE. Good to see you. Really appreciate your contributions. All right, and thank you for watching. This is Dave Vellante for John Furrier, and the NYSE Wired plus theCUBE's coverage of AI factories, data centers of the future. We'll be right back right after this short break from the New York Stock Exchange.